Yes, good morning everyone. Today we'll start our lecture with what is meant by water resource engineering. Water resource engineering is of two types. One is it consists of two parts. One is hydrology part and another one is irrigation part. Well, in the what is meant by hydrology? Hydrology is a study of science of water. Hydrology deals with the occurrence, movement, distribution and circulation of water above the ground, below the ground, and even in the atmosphere also. Hydrology deals with the depletion and replenishment of water resource of earth. So what is the objective of the hydrology? Right? What is meant by hydrology? We have seen that it is the occurrence and movement and distribution and circulation of water above the ground, below the ground, and even in the atmosphere. Well, what is the objective of the hydrology? To estimate yield from drainage basin. Drainage basin means watershed or a catchment area. Well, what are the different forms of water which is available in the earth, in the atmosphere, on the surface of the earth and below the earth? So well, in the atmosphere we find water in the form of precipitation, and on the surface we found it as a water or snow, and below the surface we will call it as a groundwater. So if you see like this, whatever the precipitation which is occurring and which is falling on the catchment system, after it has reached some catchment area, it will have some losses from the catchment area, and it will have some evaporation, and it will go into the earth surface, and it will have some infiltration, etc. So what after the process which is happened, like what after removing the losses, evaporation and infiltration, whatever the leftover water is there, it will go through a runoff. So we will study what are the different components of the hydrology and why we have to study about all these things. So what is the application for a civil engineer study of water resource engineering? So applications: design of hydraulic structures and flood forecasting and management, irrigation, municipal and industrial water supply, hydropower generation, pollution control, navigation, drought manager. These are all the applications of the hydrology. If we study hydrology, we can all work out of on these all these topics. So what is the main source of water? Water resource, world's water resource, total water available in the world is 1380 million kilometer cube. Saline water, in this total water, 97.2% is available in the form of salt water, that is saline water. Only 2.8% is available in the form of fresh water. So we have to use water so carefully. So what is meant, what saline water, fresh water, and the remaining 2.15% is available in the form of glaciers, which is locked in polar ice caps. So whatever, and we will have some underground water, that is groundwater below the ground level, which is at a depth of 800 meters below the ground. The groundwater available percentage is 0.32%, right? So in the whole these percentages, only a human can use only 0.33% for his consumption. That means 4.5 million we are using, and average annual precipitation of the world is 100 centimeters. So what is the water resource of India? Average annual precipitation is 119.4 centimeters. Geographical area is this much, and the total volume of water is 3900 cube. So this is the information about the India, and what is the evaporation happening in the India, and total net volume of water which we are having, and what is the percentage of India's water to that of the world's is this much. So this is the data which is given for the India. So what is meant by hydrological cycle? Water circulatory cycle, which shows how water circulates from one place to another place and from one form to another form with time. So what are the different components of the hydrological cycle? The hydrology means nothing but the study of the components of the hydrological cycle. So different components of the hydrological cycle are: one is precipitation, evaporation, transpiration, evapotranspiration, infiltration, and last one is runoff. So if we study these components individually, so that covers whole hydrology. So we'll start with the first component. First one is precipitation. Precipitation means what? It denotes a form of moisture that reaches ground from the atmosphere. So forms of precipitation. What are the different forms of precipitation? One is rain. We all know what is meant by rain. So in technological terms, we can define a rain as a precipitation in the form of water droplets of size greater than 0.5 mm, and intensity of the rain is greater than 1 mm per hour. What is meant by intensity? What is meant by intensity? It is the depth of water per unit time. So based upon the intensity, rains has been classified into different types. So first one is light rain, which is having an intensity of 1 mm per hour, and it should be less than 2.5 mm per hour. So the intensity of the rain is in between this range, we call it as a light rain. If the intensity of the rain is between 2.5 to 7.5, we call it as a moderate rain. If the intensity of the rain is greater than 7.5 mm per hour, we call it as a heavy rain. So another form of precipitation is drizzling. We all call it as a drizzling. So we know these terms, but technically what is the difference between rain and the drizzle? The precipitation in the form of water droplets of size less than 0.5 mm and intensity less than 1 mm per hour. We call that precipitation as drizzling. So next one is snow. Precipitation in the form of fine ice crystals of size less than 1 mm. And another one is sleet, which is also called as frozen rain. Ice crystals of size 1 mm to 5 mm. Hail, ice crystals of size greater than 8 mm. Dew, vapor accumulated during day, condenses during night and deposited on the ground as dew. We usually see these dew drops in the winter season, early mornings. So we have seen what are the different forms of precipitation. So now we will see what are the different types of precipitation. So first one is convection precipitation. This occurs due to the heating of the ground and temperature difference between the moist air and its surroundings. So how a rain will happen? So if the hot air goes up and it will get cooled down and the condensation process occurs because of that one. So because of the condensation process we will get the rain. So first of all we have to know, first thing is it has to warm air has to go up. So warm air has to go up and it has to cool down, right? So then only the condensation will happen. So what are the different types it will go up? We will see. First one is convection. After heating of the ground surface in the summer season, the ground surface will get more heated, right? Due to the temperature difference between the moist air and its surroundings, because of that one it will go up. So usually we know the moist warm air will have less density, so it will go up. After going up, the condensation process will occur and the rain will happen. This is the process you have to, if you can see, the radiations from the sun will heat up the ground and whatever the warm air will go up and will have condensation process here and the rain will happen. So next one is orographic precipitation, which we can see in the mountainous regions. What happens is, whatever the winds coming, if you consider this one as a topographical barrier like hills and mountains, the wind flows, if the wind direction is like this, wind direction is like this, it will hit the mountain barrier and it will take the reverse direction, and while it going up it will get condensation happens and the rain will happen in this area only. So this area will not have any rain, so this area we call it as a leeward side or rain shadow area. So this side is called the windward side. So in India we can observe this type of rains in the Himalayas and the Western Ghats. So frontal precipitation. So frontal precipitation is it's a front. It's a front means it is a barrier of anything. We call it as, if a pressure difference is there, if the temperature difference is there, we call it as a barrier for the frontal. So frontal precipitation will happen when there are two different types of bodies. One is warm air and another one is a cold static air. Due to there is a temperature difference between these two. So if it comes like this, the warm air will moving like this and it will go up over a cold air static air, and the warm air which is going up, it will get condensation and the rain will happen like this. In the similar way, these are two types of warm air frontal precipitation and cold air frontal precipitation. What are the difference between these is, warm air frontal precipitation means warm air body mass will be moving and the cold air body mass will be in a static position. Whereas coming to the cold air frontal precipitation, here the cold air will be moving and the warm air body mass is at a static state. And the cyclonic precipitation, we all know, precipitation which is caused by the cyclones, which happens in the low depression will be formed in the inside the sea. So it will come out on the land, and simultaneously the rain will occur due to the pressure difference between the ground and the water bodies. If the pressure is low pressure which is occurring at the water, then it will cause the cyclone. So northern hemisphere. In the northern hemisphere, we all know the globe is divided into northern hemisphere and the southern hemisphere. So in the northern hemisphere, inward and the anti-clockwise wind motion at northern hemisphere, whereas in the clockwise, if a cyclone has to happen in the northern hemisphere, the wind direction should be in the anti-clockwise direction, and in the southern hemisphere, it should be in the clockwise direction. Precipitation due to turbulent ascents. Winter rains along the coastal areas is the example for the precipitation due to turbulent ascent. Right. These are the rainfall seasons. We all know in this, we have studied earlier in the schooling what is the monsoon period, what is the post monsoon. We know everything. Winter rains, what are the winter rains, how it will happen, southwest winds, how it will occur, and how it will get diverted, and how which area will get a rainfall due to which streams, like that. We know everything in the schooling section we have studied. So with this I will end this session. In the next video we will see what is how to measurement of the rainfall, and how to measure the rainfall, how to measure the missing data of the rainfall, how to calculate the rainfall for a particular catchment area. We will see in the next session. Thank you.